In this video, I'm going to show you how to create a fruit tart in Blender. It's not a tutorial per se, mainly because to make it photorealistic, there are a lot of prerequisite work that, if I were to include in this video, like making the actual fruit pieces, it would be hours long. Instead, I wanted to show you the overall process, but also focus on the main difficult part of the tart, the crust. I don't see anyone doing that right now, and it's super important. So making a fruit tart requires fruit. Berries, strawberries, raspberries, and kiwis are all commonly used in tarts. If you're a subscriber to the channel, and depending on when you are watching this video, I've created videos on how to create many or all of the fruits in this video, but they have their own videos, so I'm not going to go over them in this one, but you can check them out if you want to see how to make them. For many berries, you can also pay and download pre-made photoscan ones. There's a few sites out there, and they vary in quality. Before starting on the shell material, let's take a look at some references. There are many kinds of shells, but the ones we're trying to make are these types. They are usually made up of two parts, the base and the wall, and measure anywhere from 5 to over 10 centimeters in diameter. Looking at recipe sites, some key aspects of these kinds of shells are that they have a lot of fine detail in the crust. Lots of tiny bumps make the overall surface, with many small holes mixed in throughout. Tart crust is very different than bread crust, which has a very solid and opaque surface with a matte finish. When we look at tart crust cut in half, it is very crumbly and has many air pockets and bubbles. If you've ever eaten these kind of tarts, the crust is very crumbly but moist and a bit chewy. Also, tart crust is a bit translucent, and this is very apparent when we look at backlit photographs. In addition, in some cases, the crust has a semi-gloss sheen to it, and it's definitely not a matte finish. While some tart crust modes create bumps on the wall of the tart, for the sake of simplicity, I'm not going to add them in our 3D tarts. So let's get started by creating the base mesh. Start with a cylinder with 32 vertices and a diameter of about 5 centimeters and a height of 1.5 centimeters. And set smooth shading. These are the dimensions for mini tarts, about 5 centimeters or so in width, since that's what I was originally creating at the time. The shader is based on the object, so if you need larger standard size tart shells, simply scale the object to a larger size. But be careful not to apply rotation and scale on the shell object or the material texture will change. This is because the noise nodes are based on the object data. If you do need to apply rotation and scale, you will have to adjust the size or scale of the noise textures for the material. We'll get to those in a bit. Create an inset for the edge and then extrude downwards to form the general shape of the tart. Create a bunch of insets on the inner surface to create some more geometry there. Do the same for the bottom. This isn't needed if the inside or bottom of the tart isn't visible. Now the key to creating crust is detail. We need to add a lot of detail. First, create a subdivision modifier with 6 divisions. If your computer can't handle this, reduce the viewport divisions down to 3. We need the large number of mesh because we'll be creating a lot of small bumps and crevices across the surface. We can't just fake it using normal maps because these small bumps and crevices create the realistic subsurface scattering effects that are needed to sell the realism, but we'll get to that in a bit. Now, we have to add some loop cuts near the edges to make the edges sharper. Also add 3 in the middle of the tart body. When we look at reference images, we see that the tart isn't a perfect cylinder, but has various bumps. And we're going to do this via displacement maps, but we don't want to displace the entire mesh uniformly. The body of the tart has a different bump pattern than the top and the bottom. So we're going to group the vertices into vertex groups to limit our displacements to only where we want them to apply. Now select the middle loops here and put them into a vertex group. Select the top loops and add them to another. Select the bottom loops here and add them to the final group. Now to UV unwrap the object. First make a seam for the bottom and inner circle. Then select some vertices up and over the tart wall for the side seam. I also created 2 seams along the top edge. Once you unwrap the object, you should get something like this. You are looking for distinct islands for the top, bottom, and sides. We'll be doing some texture painting off these UVs later on. To make the surface bumps, use a displace modifier, call it body, and set the strength to 0.0001. Create a new texture, also called body, and specify the vertex group to the body group. For the image, use a clouds texture with a size of 0.009. We should see something like this, a band of bumps going around the middle of the tart. We don't want to affect the top or bottom since we'll be using a different displacement texture size for them. While it looks quite noticeable with a harsh transition to the unaffected areas, when mixed in with the shader displacement, the effect is very subtle. For the top edge, create another displace modifier and image. Call it top and set the size to 0.0002. As before, limit the effect to just the top vertex group. For the image, use a clouds texture with a size of 0.001. After we've added the displacements, we should see something like this. You may need to adjust the strength and sizes as required when the final lighting and setup is completed, but this is a good start for now. Note, we can also easily add some more bumps on the bottom surface since we've also created the bottom vertex group, but I've omitted it for now. We can add it in later if we need to. Tarts are not perfect circles, so use the lattice modifier to make larger form distortions to the mesh. In edit mode, viewing top down, go around the tart and make some small deformations along the X and Y axis. Just select the vertices and with proportional editing on, move them around the shape so that it isn't a perfect circle. Do the same for the tart height. Select a few lattice vertices and move them on the Z axis, causing the tart height not to be perfectly uniform. We want to make subtle deformations, just enough so that the eye barely catches some imperfections in the shape. Don't go overboard. Also, the tart thickness shouldn't be perfectly uniform in width. I couldn't get the desired results using the lattice modifier or noise-based displacements, so I had to manually adjust some vertices to add some distortions to the thickness. Again, it doesn't look right if it's too perfect. That's about it. The mesh of the tart isn't too complicated. Instead, we'll be adding detail via more noise-based displacements using the shader editor. Before moving on to the material, I want to talk about my setup here. When dealing with food renders, knowing how the lighting is set up is important. So I'm using an HDRI from HDRI Heaven called Old Room. I also have 2 point lights. They both have a strength of 6 watts and a radius of 0.1 meters. This is just a start. I may adjust this later. I'm also using this gray tabletop material which has a faux marble texture and is slightly glossy. One last thing, I provided a link in the description to where you can download a sample blend file with the tart crust material node setup to make it easier to follow, so check it out if you're interested. First, we want to create a new material, and under settings, make sure that the surface displacement is set to displacement and bump. Now we're going to create the crust material. Start with a texture coordinate and mapping nodes. We're basing the color off the shape's geometry, so connect the object output on our texture coordinate node to the mapping node. Create a noise texture. Set the scale to something around 115. Now create a color ramp node. This will give us our overall color of the tart, but broken up by this noise texture, so plug that into the color input of our principled BSDF shader. Here are the color values for the high and low. Now we want to add some subsurface scattering. Remember, it's a small object, so a small amount will have a large effect. Start with something around 0.0004, but play around with this value depending on your lighting. Set the radius to 1.0 for all values, and for the subsurface color, feed in the same color ramp output. Now, unlike bread crust, tart crust is a bit translucent, more than just subsurface scattering, so create another color ramp node. We want slightly brighter colors. Here's the 2 values I used. Create a transparency shader. Plug in our color ramp output into the color input and mix the principled BSDF shader and translucency shader together at around 30%. Now, this is still looking weird. Where the magic starts to happen is when we create the bumpy texture of the crust. This texture will be created with a series of Voronoi nodes, each with their own mapping nodes, so that we can vary the bump pattern independently. First, we create the small bumps that make up the base texture. Start with a Voronoi node generator with a really small scale, around 9000. This creates a bunch of dots, but we want to isolate a specific dot pattern, and we can do this using a color ramp node and compress the white and black values. This gives us a pattern of small high contrast dots. Copy and paste the mapping and Voronoi nodes, but adjust the X location of the mapping node. This offsets the dots so they don't appear in the same locations as our first pattern. Keep the noise scale at 9000. Again, use a color ramp node to bring in the black values. This reduces the noise and creates well-formed but blurry dots. Use a mix node to combine the 2 noises. The result is a bunch of lightly blurry background dots with high contrast dots mixed in, and this is our base crust texture. Now we want to create holes in our crust. As before, create another mapping and Voronoi node, but using a scale of 2000. Adjust the X location to get a pattern you like. Use a color ramp node and bring in the black and white. This will create nice circular imprints in our crust that are not too deep. Combine this with our background texture using a darken node. Right now, the grayscale texture creates divots instead of bumps. We want the black dots to be highlights, so we want to invert the colors. In addition, the current bump map is too harsh, so we need to use a color ramp node and set the high and lows to be a dark gray texture, but keeping the right side darker. This will invert our bump map and give the impression that our crust is covered in small bumps instead of small depressions. Now to create the deeper holes in the crust, again, we use a couple more mapping and Voronoi node pairs. As before, adjust the X location field so that the bumps don't appear in the same locations. Set the scale of the first Voronoi node to 2000 and the other at 800 to create the larger holes. To create the actual dots, we need to use a color ramp node to crunch together the black and whites. Use the same value for the other noise here. Blend the first large dots with the background texture using a multiply node. Then blend that result with even the larger dots using another multiply node. Now to connect everything together. Take our grayscale bump map and connect it to a bump node. Feed in the bump node into the normal input of the BSDF node. Once that's done, create a displacement node and set the mid-level to 0 and scale to 0.003. Feed in the height from our bump map and connect the displacement node output to the displacement input of our shader output. This will create the small bumps and holes in our tart. Now we're getting some pretty nice looking results. To go the extra mile, we're going to add some small details that really push the realism. First, if we look at the reference images, notice that the top and bottom of the tart crust are darker in color, and this is caused when the real tart is baked in the oven, so we want to add this detail too. To do this, stretch a connection line from the UV output of our texture coordinate node, as we want the mask to be based off the object's UV map instead of the geometry. Now create a mapping node whose vector input is the UV data. Create a 2K image called top mask, and using texture paint, create a mask of the top edge you want to be dark brown. Make sure it's not a sharp transition. We want the edge to be gradual and noisy. Once you're done, you should get something like this. Because I painted in white, now I want to invert the mask and connect it to a color ramp node so I can adjust the strength of how brown the edges are. Create an RGB node and select a color similar to the tart crust but darker. Use a mix RGB node using the mask we just created and combine it with our base colors input and link everything together. In material preview mode, the darkness is more visible. Test it out in rendered mode to get a better idea on how subtle the edge colors are. The final level of detail we want to add is in this bottom edge. On real tarts, this bottom edge is sharp and has a different texture pattern than the wall. It looks all broken up. To do this, we need to create a mask so we limit this texture just to the bottom edge. First, extend the UV line from the texture coordinate node to another mapping node and create another texture image called bottom mask. In texture paint mode, paint the bottom edge in white. Save the image. You should see something like this. Once that's done, we have to create the bottom pattern for this edge. Connect the object data line from our texture coordinate node to another mapping node. Create a Voronoi texture with size 2000 and connect it to a color ramp node. Create another mapping node and create a noise texture with size 7000. Connect this node with another color ramp node. Combine the two with a multiply node and then add a color ramp node on the end. Finally, mix the existing bump map with the newly created bottom edge texture using the mix node using the bottom mask as a mask. When combined, you should get something like this. Notice that the bottom edge has a different texture. The final step is to replace the inputs of the bump and displacement node with this result. Do a test render. It should look something like this. If you want the bottom edge to also be dark, simply combine the top mask with the bottom mask using a mix node. This is purely optional. For this particular tart, the cream mesh is simply another cylinder with a few insets on the top face. There is a small depression formed because the filling rides up the tart wall a bit. I give it a bit more mesh via the subdivision modifier, then use some noise-based displacement modifiers for the large bumps and then another one for the small bumps. That's it. Next up is the cream filling. It's a simple material starting with a noise texture with a scale of 90 that feeds into a color ramp node to boost the glossiness. The noise is also fed into a bump node with a strength of 0.1 just to create some surface distortions to go along with the roughness texture. The BSDF node has a bit of subsurface, around 0.01. That's pretty much it. I've kept it simple on purpose since it's not really seen once the fruit are placed on top. We're now coming to the fun part, adding fruit on top of our tart. There are endless combinations of fruit you can add, so use your imagination. As mentioned before, I won't go into detail on how to make the fruit since they have their own videos, but I wanted to show you some important aspects to sell the realism. First, make sure the fruit do not have the same height and orientation. They have to look like human hands place the fruit, so adjust their heights and rotation to add some random variation. Second, sometimes fruit that is placed on tarts have a glaze on the surface. I tried fooling around with fluid dynamics to pour it on top, but it never looked right and it was always too thick. Real tart glaze is usually a very thin coating. Instead, I simply ramp up the glossy value and or add a clear coat gloss on the fruit's material. The values were specified via noise-based displacement, so the glossiness isn't totally uniform. Also, for matte colored fruit like blueberries, I also adjust the base color to make the surface look darker, to make it look wet. Let's compare some fruit from their original surface to the glazed version. I think it looks pretty good. If you're making a glazed tart, I also manually add some glazed puddles to the base of the fruit, adding some here and there just as needed. And that's it. Tarts, especially the crust, was a pretty interesting material to make, and making the PBR crust was by far the hardest thing to figure out, since I didn't want to just slap on a photograph of a tart shell as my base material. For close-up shots, you'll need a high level of fidelity, both on the tart and fruit. For wider shots, or if the tart is in the background, you can reduce the mesh on the tart significantly. I think it looks pretty good, and I had a lot of fun creating tarts, so hopefully this gives you some inspiration and ideas on your projects. Thanks for watching.